Okay, so today we'll be doing the RK4 method using C programming. So hope you have you recall the RK4 method, how it was used to find out numerical solution of differential equation where initial value were given. That means the initial value problem can be treated within RK4 or Runge Kutta method of order 4. Achha, so the problem goes like this: you write an efficient program in C to solve the following differential equation by fourth order Runge Kutta method, correct up to 6 decimal places. And this is the dy dx equals to, so this is your differential equation, and initial and final values here of the x and step length to be provided by the user. Okay, so the program is to be designed in such a way that the differential equation is given. So this dy dx equals to f of xy. This f of xy is given, but what the initial values should be. Okay, the initial values of x and the corresponding value of y at that initial value of x. What is the range of x which is to be printed, or which is to be, for which the y is to be calculated? What is the step length we should be dealing with? All those are to be asked to the user, and the user will provide those data. Only then only this program will run and give you the corresponding solution. So we have to design the code like that. Okay, so let us see how to do that. So first and foremost of all, we include the two library functions as usual. Okay, then we define an auxiliary function first. If, okay, of two local parameters or formal parameters x and y. Okay, it is a type float, and we will see gradually this will be called in the main function. So this is a returnable type function, so obviously it is not void, so we have not given the void here. Okay, and as usual what we have done here, we have defined the function to be used. Okay, so this is the function to be used. Okay, so we have taken that function here. We have declared a local variable z, and z equals to this function which is to be used. So how is the function reading here? Reading here x plus y square, so x plus y star y plus x by x square plus y to the power 3. So this power y3 gives the required y to the power 3 expression. Okay, and then we'll be returning the z. Okay, so this is the thing we have to do here, and then let us go to the main function. Okay, so inside the main function, what we will be the using, we have to declare the variables first. We take all these variables of the float type. What are the variables? K1, K2, K3, K4, K. All these, if you recall, these all are used to deal with the increment of y, h for that of x, x0 for the initial value, xn for the end value of x, y0 for the initial value of y, and xy will be used for the running variable. Okay, because if you recall back what we need there, xi equal to x plus ih, yi equal to y plus ik, or yi equal to y plus ik. Okay, so for that y, I and xi will be treated with these variables xy. Okay, now what is asked in the question, we have to ask the user or prompt the user to give the initial values. So the user will provide me x0, user will provide me xn, okay, user will provide y0, and also user will provide h. Okay, so this is C, printf, enter initial value of x. Then once the user gives it, it is scanned and stored in x0. Similarly, initial value of y, scanned, asked for. Once it is provided, it is scanned and stored in y0. Final value of x, again asked for. Once it is provided, it is stored in xn. Okay, and the step length also is treated similarly. Okay, now next we print this expression. What is it is printing? Actually, if you just try to make it clear here, what we are trying to do, we are actually trying to create a list of data. Okay, so actually x is value and corresponding y is value, we want to print like that. Okay, so we are just giving this as to give a heading of the column. Okay, x and y, and slash t, so that a gap is left in between these two, and then slash n, so that new line begins when you start printing the next whatever data you want to print here. Okay, then x equals to x0. So x, as I said, it will be used as a running variable. Okay, that the xi, and y will be used for the yi. So initialization is done here. So it has to start from the initial value. So it has to start with the value x0, x, and y as the value y0. Okay, then as we move on and introduce h and k, this will go on increasing. Okay, as we will just see now. For timing, let me just keep it as a comment line only. Okay, then we will just discuss about it later. So let us go to the while loop first. Okay, so while x less than xn, so what was xn? Xn was the last value. That means actually the, if I call it as a range of x0 was the left hand limit and xn is the right hand limit. So up to xn, that means what we do in the Runge Kutta method, it is sometimes ask you calculate the value of y at the point say 1.5. So 1.5 is the value of x where we need the y, and what we are asking the program to do here, so as to print every value of x and corresponding value of y starting from say x0 0 up to 1.5. So 1.5 is the exact value of x where we should stop calculation. Up to x equal to 1.5 we will calculate, and after that we won't do any calculation. Okay, so xn is that one. So what I am giving the command here, x less than xn. So suppose I am using the step length h equal to 0.1. Suppose I am taking the initial value x0 as 0. Suppose my last limit is xn equals to 1. So I am giving the command ki x up to 0.9. Okay, so as long as this is true, this loop will be running. Once this is violated, the loop will be, we will just go out of the loop. Okay, so within this criteria, as long as this criteria is satisfied, the program will do what? Program will calculate k1, okay, k2, k3, k4. All these are known to you. How we calculate this? What are the recurrent formula we use to calculate them in the RK4 method? This is h of fxy, h into f of x plus h by 2, y plus k1 by 2, and likewise k3, k4. This you all know. This is a part of the formula or the RK4 method only. Nothing to be different in the while we use it in C program. Exactly the same what we have done in the numerical practical. Okay, so k1, k2, k3, k4 all are calculated, and then what we need, the actual increment of y that is given by k, and this is again the part of the formula only. Okay, and then what we do, if you recall back in the what we have done in the computation table for the numerical practical, we started with x0. Okay, then we calculate all this so that we get the increment of y. H denotes the increment of x, so x1 is given by x0 plus h. Why I am saying x0? Because if you just remember, we have started with x0. So we have initialized x as x0. So once we put this, once the loop runs for one time, what will be the value given? X1 equal to x0 plus h. So it is x1, and y1 equal to y0 plus k. Okay. Again, when the loop will run for the second time, it will be giving x2 equal to x1 plus h. Okay. Because before that we have calculated x1, so x is storing the value x1 in that case. Okay, as the loop goes on, okay, the continuous structure of the loop, we know how to deal with it. Okay, so this is the x and y coming. Acha. Now you see how long it will be just going on executing the loop, as long as x less than xn. So last one, when x is less than xn, so just the value xn minus 1. Okay, so as soon as you start with xn minus 1, x we just deal with xn minus 1, it is less than xn. Okay, then this is holding good, so this loop will run. Once the loop will run, all this value will be calculated, and what was stored in x just before this step, xn minus 2 was stored. Okay, so once we do that, so sorry, once we just calculate xn minus 1 here, here it will be xn equal to xn minus 1 plus h. So xn is coming here. Okay, and then y n equal to yn minus 1 plus k. Okay, so what we are doing here, we are dealing with xn minus 1. So here this xn minus 1 plus h and yn minus 1 plus k will be calculated. So we are ultimately getting xn and yn. Okay, so once we are getting xn and yn, again if we just try to execute the loop, it will come here, but xn is not less than xn, so it will not run anymore. Okay, so the loop will be the loop will stop executing here, it will come out of the loop. Okay, Achha. Inside the loop we have given another command. What is the command we given? It is the printf command. Okay, the printing command. What is the printing command doing here? It is printing the values, corresponding values. As I said, I started with x1 y1, so as soon as x1 y1 calculated, print is giving xy. So in the first turn of the loop or first execution of the loop, what I am getting? X1 y1. So I will be getting x1 this for x, and then some gap, and then y1 again this. okay, for the first execution. Then for the second execution, x2 y2 will be coming, third x3 y3, and likewise it will go up to here. I am last getting x and y n, so x and y n will be coming, okay. And as we discussed for the last one, how we read this, we what is the accuracy level demanded here? Here we have demanded as the 6 decimal places, okay. So for that thing, this is, we have to give 6, and as I said, before decimal you can give anything, you can put 0 also, no harm in it, okay. Nothing will be changing, we will be getting up to 6 decimal places only, okay. Now if I want say six significant figures, what I have to give? In significant figures also, once you just print with first decimal places, see it what is coming. In case the answer is having some non-zero number before the decimal, then only you have to adjust accordingly ki how many digits I need here for the after decimal, so as to give that number of significant places, okay. We'll just see here in a little later. Let me just run it for 6 decimal places first and see what is coming here, okay. Acha, another thing, let me just run it first, then I will discuss the remaining this one, okay. Let us run it first, okay. So enter initial value of x, so this is coming in the screen, so we have to give the initial value, okay. So I give the initial value, say 0. Then so 0 is given, so it is, as soon as we give, computer just scans it and just stores in x0, okay. Then y0 will be given, say I say 1. Final value I say suppose 1, and step length I say 0.1. See, okay. So you see we have given the printf command xy just before we enter into the loop, this one, and after that slash n. So that means whatever we want to print after it, it will be coming in the next line, right? So it is obviously coming in the next line, if you can see from here, okay. Acha. Then I started printing from x1. If you just recall back here in the loop, I started giving the command, print command, after I gave x equal to x plus h. So it started printing from not x0, but it is starting from x1. Again, it is starting from y1, not y0. So that is why I have just said here, ki if I want to print, or if it is given in the question, ki you have to print from starting from the, say the next one after increment, then you have to write like this. But if you want to print from the initial value itself, then before while loop you have to give this printf command. Here I have put it in the comment line so that it is not executed, but once I want this also to be printed, then I will just go off with this one, and this will be executed. What it is giving? x0 y0 will be given. In fact, you can write xy also, because I am writing it after initialization and before x and y are incremented, okay. So it will obviously give x and y's value only. So suppose I give this one. Let us see what will be happening here, okay. Acha. Now before we run this for the next time, let me just discuss other parts of the output which is coming here. So xy, so first value 0.1, corresponding y's value, whatever RK4, how it is calculated, the entire calculation is done by the code we have written. So this is the coming value for y. Again, for 0.2, this is the y's value, and ultimately all this. And last we just gave the ultimate or the end value of x as 1. So it will be calculated up to 1, and corresponding value will be given. If you recall, or if you want to compare it with whatever you have done in the computation table in your numerical practical, you just see we just calculate this one only, okay. All these values we calculate, ultimately we write the answer y at the point 1 is this thing. And here what is the program is demanding, you print the whole list of values, because here we are not doing any computation table. In there we were doing the computation table, so from the computation table only the reader can understand whatever the intermediate values are coming. So suppose for 0.5 what will be the value, for 0.6 what will be the values, but here everything is done inside the code or by the code inside the computer, so anyone cannot have the idea. So we list or we print the whole list of values here, okay. So this is the thing we are done here. And in case I said if I want to print from 0.0, that means I want to print this one and this one also inside the table, then that comment line has to be done. So we just remove the backslash and then we run it, okay. Let us see how it comes. Then exactly the same thing will come, only an extra input will be there. what is the case? Acha. Here I have once I wrote it as a comment line, it was okay. It was okay because I wrote it as a comment line, and inside comment line you can write anything. But now I have just omitted this double slash. So this is now creating an error because this is obviously not a proper comment which is given. Okay. So for timing, let me just remove it. Or okay. Now let us run. You can enter initial value. So suppose I just change it. Say I change this as 1.2, and then final initial value of this 2.5, and then say final value I name it as say 2.2, and h is 0.2. Let me just see what happens. Okay, so this is coming. See, the first value I have given 1.2. Okay, x is value 1.2, corresponding y is value 2.5. So 2.5. Okay, and the remaining whatever is calculated by the RK4 method, these are all coming. Achha, you can see here there is a mismatch in the tab or indentation. Why? Because this line we have printed separately and this is printed in a loop. So all these are just giving the same structure or same pattern, maintaining the same pattern, unlike this one because it was not called in the loop. Okay, so just to adjust it, you have to give one slash more, as I can see from here, from this line. Okay, and again here also this y should be coming on the top of it. This you can adjust by adjusting the /t comment there. Okay, nothing more to be done here. So let me just give one /t more. Okay, and here also some /t more is to be needed. This you have to adjust once you get the output. You have to adjust on your own how to look it properly. Okay, this is all the required after you just observe how the answer is coming. Nothing to be done separately. Say 1.2, 2.5, 2.8, 0.2. Okay. Achha, this is again going something very separated out. We have to just keep it a bit track here. Or let me just give one slash more in this place. But you can just do one thing. Here you just 0.6 let me put. Okay. Let me put the 0.6. It's have to adjust, nothing to be worried of. And as long as the answer is correct, no marks will be deducted for this part at least. Okay, 0.1. Let me just put 0.1 only. Okay. So here it is coming like this. Okay. Another thing, as I said, whatever the answer is coming, you can see there are some thing which is coming in front, non-zero number which is coming in front of the decimal number. So if I want, suppose I want to print up to 6 decimal places, up to 6 significant figures. Okay, then what I have to give, one significant figure, one figure is already coming in front of your decimal place. So after decimal we need 5. So in that case I should be putting here 5. Okay, let us run it again. Okay, let us run it here again. See, then 2.5, then 3 step length, right? 3.4.2. Like this it is coming. Okay. So as you can see, 6 significant figures. If I demand 1, 2, 3, 4, 5, 3, 4, 5, and 6. So 6 significant figures is coming up to here. But I have not given any such thing here. Here we have to give similarly the comment here also. Then you will get exactly the same thing. And if you see here also the 6 significant. Here the 6 significant figure is coming on its own. It is not for that one because I have not given anything, any instruction for the x's part. I have given only the instruction for the y's part. Okay, and here also you can just put the same thing so as to get the similar sort of output. Okay, here after this one printf 0.6 I have already given it here, so here I should be giving 0.5, then only that thing will be maintained. Okay. Okay. So this is the RK4 method where we find out the solution and all initial values or the initial data are provided by the user. Okay. But it can also happen ki the user does not provide it. It is inbuilt in the program itself. So that initial value are already supplied to us. We have to write the program so that just to run the RK4 based on whatever data is given in at the very beginning only. Okay. In that case, what we will the difference with this one, everything will be the same, only the scanning part won't be here because nothing is asked from the user. So nothing we have to read and store it. Everything will be stored in the very beginning or initialized at the very beginning only. Okay. So for that part, the scanning part won't be there. Okay. So let me just show this here once. So exactly the same thing, only here you see this part is extra. So let me just say how to read it. So just this problem we have to solve by RK4 method for x equals to 0.1, 0.1 within bracket 1.0. What does it mean? You have to write the program so that you run the RK4 method and give the print or give the output of for corresponding value of y for which value of x? For x equals to 0.1. That means your printing should start from x equals to 0.1. It should be increasing by a step length of 0.1 and it should increase up to 1.0. So this is the end value xn. If you compare with the previous programming, this is xn, this is x0, this is h. So see, all these were previously asked from the user and now it is given beforehand. Okay. Acha. And y's value, corresponding y's value, y equal to, one thing I just said incorrect, ki 0.1 you have to show in the printing, but the it is not x0. What is x0? X0 is this one. Given y equal to 1 for x equals to 0.0. So this is your x0, this is your y0, and this is your x1 then. Because if you are increasing by a step length of 0.1, starting from 0.0, so 0.1 obviously is your x1. So here the command is you print from x1 up to xn. Need not print x0. Okay. So here this line should be in comment line and actually you should not give it here. Okay. You should not be giving this line. No need of giving the comment line. I have given it so as to explain here. But here as we demand key, we do not need that thing. We only need the printing starting from 0.1 only. Okay. So I have written it in the comment line so that you can understand it better from here only. The printing starts from x equals 0.1 and ends as x equals to 1.0 as said in question. Okay. So you do not need to run from 0. That is initial value is not to be shown here. So we just can omit this one. You can omit this line once you run your program. Okay. So this is it. Exactly the same thing you have to do here. Only see here no scanning part is there. Initial value is x equals 0.0, y equal to 1.0, h equals 0.1. So everything is there. Okay. And while here xn is, if you can store xn as 1.0 or you can just simply give the command here because here xn is fixed. You know what is xn's value. So no need of giving xn again because once you want to give xn, you have to again declare another variable, store xn in that variable, store that value in xn. Okay. So no need of doing that. You can simply just run the loop from while x less than 1.0 because 1.0 is obviously given beforehand. It is given beforehand. You have to run up to this thing. Okay, unlike in the previous program where I do not know beforehand what will be the final value provided by the user. So we have to declare a variable so as to carry that xn or the final value of x. But here there is no need of doing that because it will be supplied once before you start writing the program. So no need of taking the xn here. Okay, so I have not taken the xn in this programming. I just simply write while x less than the final value. This is the final value, so 1.0. And exactly the same thing we will be doing. Okay, so this is it. Achha. Now, depending on this, the two practicals you have to do. First one is you have to calculate this one using the Euler's method. Okay. So exactly the same thing, only the formula will be different. So you just write it on your own and just see here what I have given in the question key for. So this is required for the printing part. What you have to print. So for x 0.2, so you have to show the list of values starting from x 0.2, increment 0.2, final value 1.2. And what is the initial value? Y0 1.5 and x0 0.0. So here your x0 is 0.0, y0 1.5, and you have to show the list of values starting from the x1, so 0.2, and h is the increment. So 0.2, 0.2, 0.2, and then your value will increase for x using this one. Okay, and then you have to stop at 1.2. So you have to do that Euler method using this one. Okay, this is the practical, third practical, and fourth practical again the RK4 method. Here you see, here I have given key for x 0 up to 1.6, again increment by 0.2, and initial value is y0 1.0 at x equals 0.0. So here I am asking you to show the whole list of values starting from the initial value itself, because here it is 0, here also 0. Okay, so you have to show the whole list of value there. Okay, so you have to write the practical as or design the code accordingly. Okay, Achha. As I have already said, you have to give whatever you have to submit here. You have to submit this code one, this code file. You just save it and just send it so that I can run it and check it. Okay, okay, just don't write it by hand and send it the raw data, just written data. I won't be checking it. You have to just simply send this one. Okay, one of the components you have to send is this code file. There is a .c file, and the output which will be coming, as I have shown before also, in the what you have to do, whatever the output is coming, you have to just open a Word file and paste it here and save it and then send it as output. And here in the code file, you have to write these following things in the program file. Program file means wherever I am just designing a program, you have to write your name, date, practical number, and then the question. All these should be coming inside the comment lines, because if you do not put in the comment lines, definitely error will be coming. Okay, because once you are writing into the comment, just program code, okay, until and unless you put it as a comment line, it will be considered as a command line, and once you are giving some wrong comments, obviously error will be coming. So you have to put all this data as I am putting. Suppose I am whatever I am putting the problem. Okay, so as to understand what I am doing here, I have given in the comment line. So all this thing you have to write inside the comment line. These 4 requirements. Okay, Achha. Then give output file in a Word file is as shown. This I have shown before in the how to give this Word file in Simpson's 1/3 rule. I have shown it. Okay, and also this program code which you are writing, here. Okay, this also you can copy and put in a Word file. Okay, so send that Word file also for documentation. Okay, actually if it is not the normal procedure this time, so in case we want to prepare your practical copy, what you do, you have to give that Word file, the hard copy of that Word file. Okay, so it's better you just take a whole thing here and just put it in a Word file also. Just let me take one thing. Okay, just put it there also. Okay, save it and send it. Okay, then that thing will be coming, and so you can just save it and just send it. Okay, so what you are sending, let me repeat again, because without, if any of the component is missing, I won't be checking the practical anymore. Okay, so you are sending the code file, the program code, along with all the specifications mentioned. Okay, then you are just copying the output file in a Word file as I have shown, and just naming it suitably and just sending that output file as a Word file. So say the second component. Third component, again you are going here, you are copying the entire program in a Word file, saving it as a Word file and sending it. So you are actually sending it 3 components for each practical. Okay, the program code, the output file, and the source code written in a Word file. Okay, okay. So let me just stop here.